Okay, so this is the seat work part of the lecture, but instead of giving this to you as a seat work, this will be a sample problem. So don't worry, we'll have another separate video just like the last lecture, wherein we have a separate session wherein magsosolve lang ako ng problems. I think it really helps you a lot in understanding the lectures. And as always, I am encouraging you to practice on problem solving. Let's answer number 1. It says here, if 25.98 ml of a standard 0.1180 molar potassium hydroxide solution reacts with 52 ml of acetic acid solution, what is the molarity of the acid solution? Okay, CH3COOH is acetic acid. So this is a titration problem. So let's write first the numbers in the problem. So we have 25.98 ml. This is from 0.1180 molar of your potassium hydroxide solution. It reacts with 52 ml of acetic acid. So it reacted with 52.50 ml of your acetic acid. Okay. You are asked what is the molarity of the acid solution. So how do we do this? Ang hinahanap sa atin is yung molarity ni acetic acid. So again, the format that I've taught you in the lecture in solving titration problems is volume times mole per liter, the molality, times the stoichiometric factor, times whatever is asked from you. So in this case, binigay ko tong format na to sa lecture, molality yung hinahanap. So, ang mangyayari dito is magiging 1 over the liter, no? 1 over the liter. Yan yung format na binigay ko sa lecture. Pag molality yung hinahanap, yung last term is 1 over the liter. The volume here should be also expressed in liter. So, how do you begin the problem? So, yung stoichiometric factor, saan natin to ulit kinukuha? Kinukuha natin to sa balance chemical equation, which is already provided in this problem. Ito yung reaction, no? The balanced chemical reaction for the reaction of acetic acid and potassium hydroxide. So again, yung terms na ilalagay nyo dito should be from the same compound. So sino ba dito sa problems natin, sa problem natin, ang may volume na may molality pa? Ito siya, si potassium hydroxide. Itong volume na ito kay potassium hydroxide din naman, di ba? So ito ang ilalagay natin dito sa first two terms natin. So, convert ml to liter. How do you do that? You divide it by 1,000. So, if you divide that by 1,000, it is now equal to 0.02598 liter. Ayan. Tapos, yung mole per liter natin is what? 0.1180 mole per liter ng ating potassium hydroxide. Okay. So, magka-cancel na yung liter. Huwag nyo kakalimutan isulat kung kanino yung compound na yun para hindi kayo malito kapag ilalagay nyo na yung stoichiometric factor. So, sa balanced chemical equation for the stoichiometric factor, ang tinitingnan natin is yung compounds na involved sa problem. So, in this case, ang titingnan natin is yung coefficient ni potassium hydroxide and ni acetic acid. And clearly, ang kanilang ratio is 1:1. Ibig sabihin, 1 mole ng potassium hydroxide. Sa baba yun, para mag-cancel yung mole dito kasi kay potassium hydroxide ito. Sa taas, 1 mole ni acetic acid. Ayan. Hindi na kasya, so ilalagay ko na lang dito sa baba yung next term. After that, tingnan mo kung ano na lang yung term na hindi mo nagagamit. Yung term na hindi mo na lang nagagamit is this one. Tama? Yung kay acetic acid. So, pakisulat yung last term. 1 over, convert it to liter. So, 5250 ml, divide that by 1,000, it is 0.05250 liter. So, ayan na, lumabas na yung unit for molarity. Kasi molarity is mole per liter din naman, di ba? So, lumabas na, ayan na, mole per liter. O, input mo na lang yan ng diretso sa calculator, 0.02598 times 0.1180 divided by 0.05250 the molality of the solution is 0.06 molal. Molal CH3COOH, acetic acid. Okay. Yan na yung sagot sa number 1. Madali lang, di ba? Kasi may format ka naman na sinusundan. Ang nag-iiba lang is yung last term, depende kung anong hinahanap. Usually, kapag titration problems, either yung molarity yung hinahanap, pag molarity yung hinahanap, ito yung format na gagamitin ninyo, or yung ml, yung volume ng solution. So, pag volume naman ng solution, mag-iiba lang din yung last term dito. Pero ito, the first 3 terms, they're all the same. Now, let's answer number 2. How many milliliters of 0.1 molar, ito, volume na ang hinahanap. How many milliliters of 0.1 molar hydrochloric acid? So, ang hinahanap sa atin dito is volume ng hydrochloric acid are required to neutralize 25 ml of 0.1 molar barium hydroxide. So, the balanced chemical equation is given here. Pag hindi nakabalance yung equation, kayo magbabalance noon. Syempre, hindi kayo pwedeng mag-solve nang hindi siya balance. Yun yung first rule. It has to be balanced first before you solve the problem. Okay. So, ang hinahanap sa atin dito is ml or volume ng hydrochloric acid. Sulat natin ang given. So, how many milliliters of 0.1 molar hydrochloric acid? That is why it is very important to write kung kaninong compound yun kasi it actually helps you in solving kasi binigyan ko na kayo ng format and on the first 2 terms ang nilalagay ninyo is yung values from the same compound. So kung dapat ilagay talaga kung kaninong compound yun, no, are required to neutralize 25 ml of 0.1 molar barium hydroxide. So 25 ml, kanino tong 25 ml? Kay barium hydroxide ito of 0.1 molar barium hydroxide. Very easy, very easy. The format again, ganun pa din. Volume times mole per liter. Mole per liter is just molarity, ha? Wag malito. Volume should be expressed in liter, ha? Times the stoichiometric factor. Where do you get the stoichiometric factor? Sa balanced chemical equation, ha? Times, dahil volume ang hinahanap sa atin dito, anong gagawin dito? Invert lang natin, liter over mole. Ayan. So, this is the format when you solve for the volume of hydrochloric acid. So, very easy, di ba? As I've mentioned a while ago, dalawa lang ang hinahanap usually sa titration problems. Kung hindi naman about standardization yung tanong, ang hinahanap madalas dyan is molarity or volume. So, ito lang format na ito, o kaya ito, ang gagamitin mo lang talaga all throughout. So, it's very helpful that you are familiar with this format. So, again, yung first 2 terms dito, dapat galing sila doon sa parehas na compound. Sino bang compound sa problem, yung may volume na, may molarity pa? Si barium hydroxide. Si hydrochloric acid, molarity lang ang binigay sa atin, yung volume nga ang pinapahanap sa atin So, dito sa first 2 terms, ang ilalagay natin is si barium hydroxide. The values for barium hydroxide. Now, convert 25 to liter muna. 25 ml to liter. You divide that by 1,000. So, 0.025 liter. Times the molarity, 0.100 mole per liter. Kanino po ito? Kaninong compound? Kay barium hydroxide. Ayan. Magka-cancel po yung liter natin. Now, yung stoichiometric factor, sino ang tinitingnan natin sa balanced chemical equation? Ang tinitingnan natin sa balanced chemical equation is yung compounds na involved sa problem. At sino ba yung mga binanggit na compound sa problem? Si barium hydroxide at si hydrochloric acid. So, kung titingnan natin yung kanilang stoichiometric ratio, 1 mole, di ba? It's 1 mole of barium hydroxide. Bakit 1 mole? Kasi 1 lang po yung coefficient ni barium hydroxide. It is equal to 2 moles of hydrochloric acid. Bakit 2 moles? Kasi 2 yung coefficient ni hydrochloric acid. So, sa baba, ilagay natin, mole ni barium hydroxide, 1 mole over 1 mole ni barium hydroxide. Ayan. Sa taas, 2 moles ni hydrochloric acid. Okay? So, magka-cancel po ito at saka ito. So, yung next term, dito ko na ilalagay sa baba, no? Sa last term, check mo kung sino yung given sa'yo na hindi mo pa nagagamit. Ito. ito, parehas lang naman yan dito sa 0.1 mole per liter. Tama? Kaya yung last format is liter per mole kasi i-invert lang natin siya. So, yung 0.1 mole per liter, gawin natin siyang 0.1 mole sa taas liter. Para lumabas yung unit for the volume. So, magka-cancel si mole, may iwan si liter. So, nakuha mo yung volume. So, 0.025 times 0.1, input yan sa calculator, 0.025 times 0.1 times 2 divided by 0.100. Oh. Wait, let me input again. Nagkamali ako ng input. 0.1 times 2 divided by 0.1. Ayan. So, the answer here is 0.05 liter. Ang hinihingi sa'yo sa problem is what? Ang hinihingi sa'yo sa problem is milliliters. How do you convert liter to milliliters? Multiply it by 1,000. So, times 1,000, 50. Ayan. So, this is equal to 50 ml pure hydrochloric acid. Ayan. Check ko lang yung pag-input ko, no? Nagkamali ata ako ng pag-input ng number sa calculator. Times 2 divided by 0.1. Okay, 0.05. There you go. Madali lang, di ba? The last problem is about standardization. So here, actually, the technique with titration problems, it's the easiest. It's just like having a puzzle. All you have to do is just cancel the units, no? Kapag standardization ng problem, lagi tayong nagsa-start dun sa grams ng ating KHP, potassium hydrogen tally. So this one, si potassium hydrogen tally, usually ginagamit ito sa standardization ng what do you call this, ng sodium hydroxide, no? Pag ang titrant mo is sodium hydroxide, ang ginagamit mo na primary standard is potassium hydroxide. So, ang molecular mass ni potassium hydrogen tally or KHP is 204.22 gram per mole. Ayan. So, yan yung kanyang molecular weight or molecular mass. Okay, iba-iba yan, no? Iba-iba yung mga primary standards na ginagamit. Depende kung ano yung ating titrant. Ayan. Okay. So, for number 3, in a titration experiment, a student finds that 23.48 ml of sodium hydroxide solution are needed to neutralize 0.5468 grams of KHP. Pag standardization problem, you start with the grams. First step is convert it to mole. So, divide mo yan, 204.22 grams sa taas, 1 mole of KHP. After that, ayan, so ang format is you start with the grams, tapos convert it to mole, and then stoichiometric factor. Usually nga, dahil ginagamit to sa standardization ng sodium hydroxide, 1:1 ang ratio nila, ibig sabihin 1 mole is equal to 1 mole. So, dito sa baba, 1 mole ng KHP, sa taas, 1 mole ng sodium hydroxide. Ang hinahanap natin dito is molarity ng sodium hydroxide solution. So, kaya tayo nagsa-standardize sa titration, it is because we want to know the exact concentration of our titrant. So, yun yung first step. Bago ka makapag-titrate, mag-standardize ka muna ng iyong titrant. Ayan. So, sa baba, ilalagay ko na lang, no? 1 over the liter ito. So, 1 over, ano yung binigay sa atin na volume here? Isa lang. So, 0.02348 liter. Ayan. Actually, ang technique lang dito is to cancel the units, no? You have to cancel the units. So, mole. Ayan. Ang natira is mole per liter kasi ang hinahanap sa atin sa problem is yung concentration ng sodium hydroxide. So, 0.5468 divided by 204.22 divided by 0.02348. So, the molarity of your sodium hydroxide solution is 0.1 molar. Ayan. Let me input that again in my calculator to make sure na napindot natin na maayos. Divided by 0.02348. Okay. Again, 0.5468. Tama ba? Ayan, 0.5468 grams. Divided by 204.22. Divided by 0.02348. Ayan. 0.1 molar, tama. Okay, so wag kayong mag-hesitate no na i-input ng input sa calculator ninyo kung unsure kayo dun sa pagkapindot nyo, no? And I know the standardization process, medyo nakakalito siya. Actually, the only way to really understand the titration problems is very easy. But if you really want to understand the entire process of titration, kailangan gawin mo talaga siya sa lab. So I think I'll just post a separate video about the procedures done in the laboratory. How do we standardize our titrants? And when do we use a blank solution? Ayun, siguro I'll just add this as part of your supplemental materials, no? Para may idea din kayo paano ba ginagawa sa lab. Kasi I understand na ngayong summer class, though may mga gamit na tayo sa school for titration, hindi natin siya magagawa kasi wala naman tayong laboratory sa bahay, no? Anyway, that's it. So, I'll post more titration problems and dilution problems to help you with your exams. Ayun. Have a good